Hello everyone. Today we're going to be talking about molar volumes of a gas at STP. Now STP stands for standard temperature and pressure. So at STP, every gas, regardless of what it is, occupies the same volume per mole. So this relationship is one of the most straightforward in chemistry and it underpins a large number of stoichiometry calculations. So if we start by looking at what standard temperature and pressure is. So the STP, or the standard conditions, is at a temperature of 0 degrees Celsius. So at STP, the temperature is 0 degrees Celsius, and the pressure is 100 kilopascals. So 100 kPa. And these two things combine to create the standard temperature and pressure. Okay, now let's talk about molar volume. So molar volume is the volume occupied by 1 mole of gas at a specified temperature and pressure. So if we look at ideal gases, we'll talk a little bit more about them in a future video, but ideal gases have a molar volume. So molar volume is represented by this symbol here and is equal to 22.7 liters per mole. This is for ideal gases at standard conditions. That's if it's a ideal gas. Okay. So this value applies to all gases under ideal conditions. It does not matter whether the gas is oxygen, carbon dioxide, hydrogen, or anything. 1 mole of any gas occupies 22.7 liters at the standard conditions. Now this is related to Avogadro's law, which states that equal volumes of gases at the same temperature and pressure contain equal number of particles. So now let's talk about the relationship. So remember that an ideal gas is any gas that is at those conditions. So it's at a temperature of 0 degrees Celsius and a pressure of 100 kilopascals. So the relationship between volume, number of moles, and molar volume is expressed like this. So the volume of a gas is equal to the number of moles of a gas times by the molar volume. Okay, so V is the volume of the gas, and that is usually in liters, and N is the number of moles. And then we have Vm, which we already talked about, which is the molar volume. So you could be asked to rearrange this equation to find any one of these three things. Now, the relationship is linear, meaning the number of moles doubles the volume at a constant temperature and pressure. Now, we could go through a worked example for this now. So let's say the question is asking us what volume does 3.5 moles of nitrogen gas occupy at STP. So we're trying to find the volume, and we know that the moles is equal to 3.5, and we're told that it's at the standard conditions, which means that Vm is going to be equal to 22.7. So then if we put this into the calculator, we get V is equal to 3.5 times 22.7, and then we get a volume of 79.45. And that's going to be in liters. Okay, and you can always rearrange it as well to calculate different things. So to summarize, at standard temperature and pressure, 1 mole of any ideal gas occupies 22.7 litres. This is the molar volume at STP. The relationship here allows you to convert between volume and moles directly if the gas is at STP. You can rearrange the formula as well